Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Pvt Limited. I have 14 years of work experience in the fields of artificial intelligence, software development and robotics. This is part 2 for digit classification project. Let's continue. What we require is, of course, for plotting the chart, if you remember, I told that I will be using these charts in the future sessions. So this is matplotlib, and you can see for plotting the things, these are available in matplotlib. And the TensorFlow, of course, you will require TensorFlow. This is the core library for building and training neural network. And for what matplotlib is for visualizing data and results. Now comes the part MNIST dataset. This is the dataset we are using. What it contains is, so dataset is collection of 70,000 handwritten digits. What dataset this dataset contains is 70,000 handwritten digits from 0 to 9, split into training and testing sets. I told you in earlier sessions many times that whenever you get a data set, you have to split into two parts, training set and testing set, so that you can train the model and test if it is working using the remaining testing set. So each image that this data set contains is 28 by 28 pixel in grayscale. This is what it contains, 28 by 28 pixels in grayscale. So this is what it is talking about. And training, when we distribute this to training set, 60,000 images will be used for training set, 10,000 will be used for testing set. Comes the part of building the neural network. So you have to import TensorFlow, Keras and layers from Keras, matplotlib for plotting the charts. So let's see. Load the dataset, MNIST dataset. This is how you load it. You don't have to separately download the dataset. It is already available. You don't have to download it from some external link. Dataset is already available in keras.dataset.mnist. Okay. So this is how you break down the things into two parts: train images, train labels, test images, test labels. This is how you can break the data in two parts. Then comes the part normalize the images. I will tell you each and every line what it means. So let's see explanation. The pixel values in the MNIST dataset range from 0 to 255. The pixel values in the dataset range from 0 to 255. What it means? So because they are grayscale images, here 0 represents a black and 255 represents white. So if we have values between 0 to 255, some value in middle, so with values in between representing varying shade of gray. So if we have 0, it represents black. If we have 255, it represents white. And if we have something in between, it represents shades of gray. This is what it means to 255 here. Now what this code means is, by dividing the pixel values by 255, you scale them to the range 0, 1. This process is called normalization. So we are not interested in this color scheme for now. To look at the shades of gray, we are not interested. what we are interested in is just 0 or 1. So either it can be black or either it can be white. So this is what we are interested in. But so in from the data set, what we will get is 0 to 255 values. But if we divide with this value, what we will get is 0 or 1, and this process will be called normalization here. So what we are doing in this line is normalizing the data. How? By dividing it with 255. Why? Because we are not interested in varying shades of gray. So this is what these lines means. Normalize the images to 0 1 range. Now again, why normalize? By normalizing improved model performance, neural networks often perform better when input data is normalized to a small range, typically between 0 and 1 or -1 and 1. So neural network often perform better when input data is normalized to a small range, typically between 0 and 1 or -1 and 1. This helps the model converge faster during training and can lead to better result. So if you normalize the data, model will run faster. This is the thing. Then comes the numerical stability. Large input values can cause numerical instability during training. Example, very large gradients. Normalizing input prevents this issue and ensures stable training. Again, I told you in previous sessions also, if you have big data, so we applied many techniques in previous projects also to normalize the data. And if you remember the outliers and everything that I told in previous sessions. So to solve the problem, normalization is very important, because you will be dealing with huge data. So you have to keep things small or data small or targeted. So this is one of the method for normalizing. At least for this project, we are using this method for normalizing by dividing it with 255. What this output means is 60,000. So what I told you, what 60,000 is, it contains 70,000 handwritten digits. So we are using for training 60,000. And what 2828 means is, as you know, it's 28 by 28 pixels. The handwritten images are 28 by 28 pixels. This is what it is. I have mentioned everything here also. So here this means, this indicates that there are 60,000 training images in the dataset. 28, each image is a 28 by 28 pixel grayscale image. This means each image has a height of 28 pixels and a width of 28 pixels. So the shape, this means you have a dataset containing or consisting of 60,000 images, where each image is a 2D array of 28 by 28 pixel values. This is what this means. And what this second line means, so this is this indicates there are 60,000 labels, one for each of the 60,000 images. The shape, this means that it is one dimensional array containing 60,000 label values, where each label is an integer ranging from 0 to 9. So each label, what these lines mean is, it contains digits, that I already told you, contains digits. So ranging from 0 to 9, representing the class of the corresponding image. Each label corresponds to the digit depicted in the respective image. Then comes the part of visualizing the data. As you can see, I am plotting the data in the matplotlib. I am plotting the data in matplotlib. So this is how you can plot visualizing the data, and this is optional part, but for the debugging I have included this. This is how you plot the things. If you remember, I am show and all this, so don't worry, I have included the things here. So if you look at this subplot, this is where you will find what this is all about. So I have included here, these are n rows and columns. N rows, first one, n columns, third one is index. This function is used to create a grid of subplots, small individual plots within a figure. So if you can see small plots, this is what it is talking about, small plots. So this is what subplot is doing, small plots. Then comes the part of the parameters. N rows 5 specify that the grid should have 5 rows, n calls 5, 5 columns, 5, 5. Index I plus 1 specifies the position of the current subplot in the grid. So you cannot plot everything on top of each other, so you have to give. I is a loop variable 0 to 24 in a loop of 25 images. So how many images are we plotting here? 25 images. So I plus 1 ensures that the position is 1 based because subplotting index start at 1 and not 0. So how to subplot things? This is how you can subplot things, and it is already available. This subplot feature is already available in matplotlib, and we are not doing something special. It is already available in matplotlib. We are just passing the index values using for loop like this. So whenever I comes, it will be incremented by 1 and plot will be created. So this was some basic about plotting the chart like this, subplot. Remember this, subplot in matplotlib. I will continue this session in next video. See you in next video. Have a nice day.